Good morning. Today we'll learn how to use React hooks. We'll go through their typical applications and then we'll learn how to test them. We're going to discuss useState, useReducer, useEffect, custom hook using useState, custom hook using useEffect, how to test custom useEffect hooks, how to test custom useState hooks, custom hooks that are using subscriptions to event listeners, and then in the end of this video I will give you a recommendation where to go next to learn more about the hooks, get inspired, and to find custom hooks to use in your projects. The useState hook is the most basic of them all, and it just allows you to store one value bound to your component. And usually you will use it when you need to store some simple value, for example an integer, like in this example it is a count value. To use the useState hook, you need to define the getter and setter. You do it inside of the square brackets, because useState returns an array of two values, the getter and the setter for your value. Let's call it count, and the setter will be called setCount equals useState. We can also specify the default value. In our case, it will be 0. As you can see, we now get an error, and it means that we need to import useState from React. Now, we can assign click listeners to our buttons to call the setCount. OnClick equals a function that we'll call setCount count plus 1. And to decrement, we'll define another function onClick equals setCount count minus 1. Now we can click increment and decrement, and it will update our state. As you can see, there are very few moving parts here. You call the useState with the default value that you can provide optionally. By default, it will be undefined. You receive an array of two elements. The first one will be your value, the getter of your value, and the second one will be the setter, the function that you can call with a new value to set your state. And then whenever you want to update the state, you call your setter. So in our case, it will be setCount. And if you use JavaScript, then we can even provide a string to it, test. As you can see, every time you call the setter on your component, you trigger the re-render. In case of the functional component, it means that the whole function body will be executed once again. And if you call the setter, which in turn will trigger the render one more time, and then we are stuck in the loop. If you want to call the setter only once when your component is mounted, you can use the useEffect. useEffect we also imported from React, and now we pass a callback and an empty array for the dependencies. We move the setCount inside of this useEffect hook, and now it works. The initial value of our state that we will render will be now test. If you want this useEffect callback to trigger every time some value changes, you can pass it in the dependencies array. Right now the array is empty, which means that our useEffect is not observing any value, and it will trigger only when the component will get mounted. If we pass the count value to it, then it will reset the value of our counter to the string with the value test every time we click increment or decrement. When I click decrement or increment, you now see that it blinks for a fraction of a second, but then is immediately reset to the string test. We will talk more about the useEffect hook later in this video. For now, remember two things about the useState. First, it triggers re-renders on update whenever you call the setter. And second is that it's generally meant to be used with simple and independent values, like strings or numbers, maybe even objects, but then it can become kind of tricky, and it might be better to write the logic using the useReducer hook. Let's see another example. Here you want to create an app that will allow you to take and remove nodes. Let's say new node, press add node, it's added to the list, we can add another node, add node, and then we can remove them. Let's see how to create such application. Here we have a component with a list of nodes. For now it's hard-coded as an empty array. We have an input ref that we've created using another hook called useRef. It's used to create the references. And then we've passed it to the input field. The refs hold references to the actual rendered HTML elements. In our case, an actual input. We can address them using the field called current, and then we can interact with all the fields that the original HTML element would have. So for example, input has the value field. We use it here to reset the value of the input after we add node. If I try to enter some text and then click add node, it will clean the input, because the button has the onClick handler called add node, which gets triggered when I click it. It calls input ref current, the current reference that the ref object is storing, and then it sets the value of this input to be an empty string. Now, we need to render the list of nodes. That would be an unordered list of elements with node names and buttons with X characters that will allow us to remove the node items. This is a good use case for the useReducer. Let's remove the hard-coded nodes and call the useReducer. Just like with useState, you get the array with two elements. First one is the getter, the actual value. It will be nodes, but the second value will be the dispatch function equals useReducer. We'll talk about the dispatch function a bit later. Right now we need to provide the reducer function that will calculate the value of our state and the initial value. So let's provide the reducer function. We'll write the logic a bit later. And the initial value, which will be an empty array. Okay, now let's get back to the reducer function. Reducer function receives the previous state value and the action and returns the new state value. So we need to define the state argument and the action. Usually reducers are written using the switch case statements. We switch the action type. Actions are objects kind of like events, and they are required to have the type field, and they can also have the payload, which is some data attached to the action. So we look at the type field, which is a string, and then depending on its value, we perform different calculations with the previous state. We'll need to handle two action types, add and remove. So we'll write case add, then we'll do something here, and then case remove will perform something different. If we got some unknown action, we need to add the default case, where we'll just return the previous state. Return state. Now, inside of the add case, when we want to add a new item, we will return the new value for our state, which will be an array. We'll spread the previous value of the state here. So at this point, we've created a new array, and this is important. You always need to create a new value inside of the reducer. So we got the new value with all the items from the previous state. Now we need to add a new one from the action. So we add a new object with ID that will generate using the nano ID. Nano ID is not found, so let's install it. Yarn add nano ID. Import nano ID from nano ID. This function will just generate a unique identifier for us. And then we'll need to set the name using action name. Now that we have the add case defined, we can start dispatching the add actions. And this is what dispatch function is for. It is for dispatching the actions that will then be used inside of the useReducer to calculate the new state value. So we go to the add node function, and here we'll call dispatch. We define the action inline. As I said before, actions are just objects with a mandatory field type, which should be add in our case. And also we need to pass the name for our reducer. Let's pass the name, input ref, current value. Let's make sure that we dispatch before we actually clear the input value. And now we can try to create some nodes. Some node. Add node, as you can see, is being created. The removal doesn't work yet, so let's implement the remove case. Here we'll return the state where we filter the items where ID is not equal action ID. Now we need to define the remove callback on click equals function that will dispatch new object type remove ID node ID. Let's add a node and now remove it. Everything works. Now, what's important here? When you manage the state using the useReducer hook, you will get the value and the dispatch function. The dispatch function is used to trigger the new state recalculation, and the logic to recalculate the state value is defined in the reducer function. It is very important that this reducer function is pure, which means it should not have any side effects, and it should be deterministic, so that for any specific state value and action, it should return similar results no matter how many times you run it. If you still don't know what to use useState or useReducer, then I recommend reading the article by Kenzie Dodds, Should I Use useState or useReducer. It should help you and give you some solid ground. So far we've only been using the built-in hooks, the useReducer, useState, useRef, useEffect, but you can also create your own custom hooks. And to do this you just need to define a function that starts with word use. Let's see a couple of examples, and we'll start with the most basic state custom hook. We are going back to the counter example where we can click increment and decrement buttons and it will update the counter like in many other counter examples, but now, instead of defining the useState hook and then manually defining the callbacks on the increment and decrement buttons, we are using the predefined useCounter hook that exposes the count, increment, and decrement functions. One of the differences that you can instantly see here is that it's using the curly brackets. That also means that it's a bit harder for us to rename the values. We could still do it using the colon and then new name syntax, but we don't need to do it here. Instead, let's go inside of the useCounter and see how is it implemented. So as you can see, it is a regular function that starts with the word use. This is a convention of how to let the users and React know that it's going to be a hook. Then goes the thing name. In our case, it's counter, so the name is useCounter. And inside, we need to store the state. So we use the useState from React. We can actually remove the React from here and instead import the useState from the React module. We set the default value to 0, like we did in our first example, and we also define the increment and decrement functions right inside of our hook. And then we expose the count and our setters through our return statement. In fact, as we don't have any JSX here, we don't even need to have the React in our namespace. So we can just have the useState. Now let's talk about testing such hooks. To do this, there is a great React hooks testing library, which I'm going to show you in the next example. Here I'm going to test the useCounter hook that we just looked at. I'm going to use the React testing library with the React hooks add-on. When you use React hooks testing library, you have the render hook function. Inside of your test, you pass your hook to it, you get the result object that will have the field called current. This field, current, will have the fields of your hook available to you. So in our case, it's the count, which is a number, increment, and decrement. I'm going to call the increment function. As it's going to update the state, I need to wrap it into the act method, which I do here. And then I can compare the new count value to the expected one. The default value was 0. When I called the increment, it became bigger by 1. So it should be 1 now. As you can see, the test is passing. And I can test the decrement function the same way. Render the hook, get the result, call the decrement function of the current field, and then compare the count with the expected value. The example code both for the useCounter hook and for the test for it will be in the description of this video. Custom hooks that only use the useState hook inside of them are quite easy to work with and test, but sometimes you need to have the hooks that will perform some actions automatically. For example, you might want to have a hook that will automatically fetch the data from the server when you mount the component that uses it. So let's look at the custom hook that uses the useEffect internally. Here we have an app that loads the information about the Pokemon. For example, let's try to load another one called Ditto. We have the Pokemon image and the name. The hook automatically manages the loading state and will provide an error if something will go wrong during the fetching. If we are still loading the data, we will show the text loading. If we have an error, we'll show the network error. And if we got the data inside of the Pokemon object, we will show the image and the header with the Pokemon name. Let's see how does this hook look like. As you can see, this hook is considerably bigger than previous examples. It also now accepts the values. Yes, you can do it using hooks. You can pass the values to them through the arguments, which we do here. We get the Pokemon name, and then we define 3 use states. Those 3 values don't depend on each other, so for me it was easier to implement it using 3 use states instead of the useReducer. And then, when the hook will get mounted, or rather when the component that will use it will get mounted, the useEffect will get triggered, and also it will get triggered whenever the Pokemon name will be updated. Remember that the second argument of the useEffect is an array of dependencies. If it's empty, then the effect will run only once when the component will get mounted. And if you pass the values to it, it will be called every time the values inside of this array will change. When it happens, the useEffect runs the callback, where we define the fetch data We do it because the fetch data is a synchronous function and useEffect doesn't support the asynchronous callbacks. So we define the fetch data function and then immediately call it. As I said, fetch data is an async function where we set the isLoading to true, and then we try to fetch the data from the Pokemon API using the Pokemon name that we've passed through the arguments. We get the JSON by parsing the response, and then we set the Pokemon object to have this fetched Pokemon data. If something goes wrong, then we set the error object. And finally, we set isLoading to false. Just like in custom state hook example, we expose the values using the return value, Pokemon, error, and isLoading. And now they're available inside of our app. If you worked with hooks before, for example, the useEffect hook, then writing the custom hook that will use the useEffect internally is not that hard. Basically, it's the same as writing the component, but instead of returning the layout, you return an object with the data that you fetched. But it might be tricky to test. So let's figure out how to test such custom hook. So there are a bunch of things that I want to test here. First, I want to make sure that the value that we pass as a Pokemon name is respected and we actually call the fetch with this name included. So I have the test case for it. I test that it fetches the Pokemon by the URL constructed from the Pokemon name. That's the first thing. Then we have three states. We have the loading state while we're still fetching the data. We have the successful state when we got the data. And then we have the error state. We want to process all of those states properly. So I have three describe blocks, one for each of the cases, while fetching data, when got data successfully, and with an error during the request. I like to organize my tests using the describe blocks, and often I actually use the to-do, to plan the tests ahead of time. And if you use the to-do syntax, you don't have to write the test body. You can just leave it like this, just with the test name, and think about the test implementation later. So, while we're fetching the data, we want the isLoading field to be true. How do we test it? To do this, I had to create a function that returns a modified promise. We create the deferred object that will hold the resolve and reject functions from the promise instance. I create the new promise instance, store the resolve and reject inside of the deferred object, and then return the deferred that holds the resolve and reject and the promise itself. I will use this promise to mock the fetch and the deferred object to control our promise. I call the getControllPromise, mock the fetch function. Now I return this promise that I can resolve whenever I want to. I render the usePokemon hook. And then first I want to make sure that isLoading is true. Then I resolve the fetching promise, wait for the next update. I have to use this function because we're using the async operation here. And then I expect the isLoading became false. It might look a little bit complicated, but let's look at it again. So first we prepare the promise that will be able to resolve at will whenever we want to. Then we mock the fetch with our fake promise that we can resolve at any moment. Then we render the hook with our familiar render hook function, we get the result and another wait for the next update function that we need to use here because we're dealing with async functions. Then we first check that isLoading is true because the initial state should be true. We call the resolve function on the deferred object. We resolve our promise, wait for the next update, and then make sure that isLoading is now false. Now let's go to the next test case. What happens when we load the data successfully? The beginning is basically the same. We still need to be able to control the promise. I render the hook, call the deferred promise resolve method with function JSON that returns the object Pokemon Pikachu. If we go back to the usePokemon implementation, you will see that here is the JSON function that we're trying to mock. And then I want to make sure that the Pokemon value equals the value that we've returned from the mocked JSON function. Basically, we're testing that we've stored the value that we got from the fake backend. And finally, we need to test that the error will be handled gracefully as well. Here, I don't need to use the control promise. I just mock the fetch function with the promise that instantly throws an error. I render the hook, use Pokemon, and then I check that the error equals the error that I'm throwing in my mocked promise. And that's basically it. Again, the example code will be available in the description. There is also another kind of useEffect hook that needs some extra care. It is a hook that subscribes to events. For example, adds event listeners to the window object. In this example, we're tracking the mouse movements. when the component that uses this hook will mount, we will add an event listener to window and listen to the mouse move event. We'll handle the event using the event handler, basically setting the position to our state. But then you need to remember that if you begin to listen to some event, when your component unmounts, you need to remove the event listener, otherwise you will have the memory leaks. How to do this? You need to return the function from your hook, either inside of the custom hook or in the component. It actually has more to do with how does the useEffect hook work. So when the component is unmounted, it calls the function that you can return from the useEffect hook. In this case, I return a nameless function that removes the mouse move event listener from the window. You can think of it as an off-analog of the component will unmount lifecycle method. We've just walked through the most common custom hook types, and you might be wondering what's next, where should you go after this video? And today I want to recommend you two places. First one is useHooks. It's a collection of different custom hooks with their implementations and the examples of how to use them in your applications that you can use to get some inspiration, or maybe really just get them from it and use in your apps and projects. And also the awesome React hooks list on GitHub that contains the list of videos, articles, and packages with custom React hooks that you can again get inspired by or actually use in your projects. Thank you for watching. Let me know in the comments what else would you like to know about React, and also join my Discord server to pick the topics for the next videos. See you next time.